had to guess, I would say everyone's gonna take DeepSeek's approach. They're gonna learn from it. They're gonna try to take it two or three or four steps beyond that, right? So then that means potentially in 5 years, we're not gonna need a model that's a trillion parameters. You might only need a model that's only 100 billion parameters.
Welcome to Practical AI, everybody. My name is Jeff. I'm here with Peter Lynn. Practical AI is brought to you by Pocket AI. Pocket AI is a tool you can use to edit the weights of your model. With Pocket AI, you can prune over 60% of the weights of your model without decreasing accuracy. One final note here, be sure to put us on double speed because Peter and I are notoriously slow in how we talk, and you can get through these videos pretty quickly. Peter, today's topic is about Groq, but not the Groq that most people are aware of, not Elon Musk's model, which I think just came out with Groq 3. We'll talk about that another time, but today's a little bit more on the hardware side. NVIDIA has a competitor, I think, named Groq as well, but it's Groq. So tell
Right.
us about this and why it's important.
It's important because most people think of AI, they think of training, and they don't necessarily think of the inference and runtime. So inference is really after you've trained it, you want to run it so that when someone goes to ChatGPT, that's inference time, right? So it's someone actually asking a question to a chatbot. And broadly speaking, I mean, there's a lot of different ways you can compare the two. If you were to ask Grok and NVIDIA, they're not really competitors because Grok is all about runtime and inferencing, and it's not about training. And NVIDIA's focus primarily has been training, but they're probably going to start getting to inference more in the future. So, broadly speaking, the simplest way that I can explain it is NVIDIA's architecture is more of a batch based, meaning that like you load your model, you load your data, and then you tell it, do this work for me. And under the hood, there's a lot of magic. Their framework, CUDA, takes all that work and it chunks it up and figures out what's the best way to run this stuff as fast as possible. In contrast, Grok's hardware is a bunch of small processors that are specially made to do inference. But the big difference is that they use what's called SRAM, static memory. And so if you have static memory, what happens is you can load up your models. Let's say you're using Llama, you load up the 7B or the 8B or the 70B or whatever, and it loads all the model into memory. And so it's not batch based. This is what's called streaming or real time, meaning that when you and I give it a prompt, the only thing new you're feeding it is the actual prompt data, which is pretty tiny. It's only a couple kilobytes at most.
Okay, so you kind of like opened up something that I hadn't really thought of too much, and that is that you could use hardware to train and you could use hardware to run, essentially,
Yeah.
right? So how how much is this done? How much is hardware being specifically dedicated just to train, and then you use a completely different type of hardware to run?
So right now, most everyone uses NVIDIA stuff to do both. But AMD actually last year started to kind of eat into NVIDIA's market share. And so their focus is on runtime. So for example, AMD's GPU has a lot more memory because it's designed specifically more towards the inference and runtime and less for training. Because going forward, people might train for 12 to 16 or 18 months, but as we scale up chatbots and stuff like that for business, you're going to see a much bigger demand for the runtime, for the inference.
And Groq, the hardware company, introduces, at least to me, some acronyms that I wasn't familiar with originally. So we've got on the classic sort of computer chip side, you've got CPUs.
Yep.
You've got GPUs that are kind of more thought of in the NVIDIA space. And then what do we get introduced to in the newer tech that's kind of in this runtime space.
So they're calling theirs LPU, language processing unit. Yeah.
And what?
Yeah.
How is that? You've kind of already explained it, but just give us like a CPU, GPU, LPU, real quick.
So CPUs are designed to do kind of pretty much everything, anything, but not really fast. Whereas GPUs are designed specifically to take the same chunk of data, break it up, and do the same operation across all the data in parallel very quickly. So that's why when you train on GPUs, it's anywhere from 5 to 20 times faster. Right. So if you're training, let's say, a language model, something that would take you a month to do in a GPU might take you 10 months on a CPU.
And the LPUs?
So LPU is really just for runtime. You wouldn't train on them.
Okay. And is it processing more closely to a CPU than it is to a GPU, or is it totally different?
It's totally different. It's really designed to have. So the idea is you have a bunch of really simple processors with static memory, and then you can just load. So let's say you have Llama 70B. So you go, okay, I got a 70 model. How big is it? So let's say it's 70B. So let's say it takes you 600 gigabytes of memory. So you just go, how many LPU processors do I need? And you just divide it up. Then you just load the model onto it, and then when you ask it a prompt, it takes the prompt, it tokenizes it, and it just feeds the whole thing in parallel through it. So think of it this way: a GPU is kind of like a highway, and you've got semis delivering things in parallel. A CPU is more like a two-lane street, whereas an LPU is more like a thousand-lane highway. And so you can do a lot of things very quickly.
Got it. And instead of semis, you're using motorcycles.
Right, using like cars, but you've got 1,000 lanes. It's not just,
Right.
like if you're on the 405 freeway in LA, you've got 8 lanes on each side.
Yeah.
And if a semi tips over, then you're screwed because now you've got gridlock.
Got it.
Which if you've driven away, you know what happens.
Okay. So you said earlier that NVIDIA doesn't see Groq as a competitor.
Yeah.
Well, how do you see it? Is it one of those things where like 10 years from now we're like, yeah, of course, companies like Groq just crushed it. We should have bought their stock, the whole thing. Or is it truly going to be partitioned off into like they're going to do their thing, we're going to do ours?
If I had to guess, I would say everyone's gonna take DeepSeek's approach. They're gonna learn from it. They're gonna try to take it 2 or 3 or 4 steps beyond that, right? So then that means potentially in 5 years, we're not going to need a model that's a trillion parameters. You might only need a model that's only 100 billion parameters. So when you get to that size, now, okay, do you really need a million H100s? You probably don't. Because if you're going to do that for training, you're only going to train for a certain amount of time, but for inference, you're going to run it all the time. You're going to have, so let's say you get half of the US, and the US is what, 300 million people, right? So that's 150 million people. So that means you need to do processing for 150 million people all in parallel, right? If everyone is using some kind of a chat tool, so now you got to scale out. So that means the demand for things like LPUs are going to grow exponentially.
Okay, so you're bullish on the LPU side and still bullish a little bit on the GPU side, but you see room
Yeah,
for Grok to compete here and pick up market share or create market share.
I think eventually NVIDIA will probably buy them out. That's my guess. Yeah,
Awesome.
because like you can't run GPUs serving half the country in a cost effective way. It just eats too much energy. Like you literally can't because there's not enough power.
Well, we'll put the a pretty good YouTube video chat with I think the CEO of that company, Grok,
Yeah.
up so you can watch. It's long, right? It's an hour, but one thing that he does say is that he's bullish on power, right? Like we're going to need data centers, we're going to need more power, and even if we hit a little lull because we overbuilt early, the need
Yeah.
for data centers is going to continue. So um,
Oh yeah.
it doesn't seem like even he thinks that they'll be eliminating data centers anytime soon.
No, I mean for sure we're gonna need in the next 20 years 10 times the power
It's
at
crazy.
minimum.
That's
At
crazy.
minimum.
All right. Well, good discussion, Peter. We'll keep an eye on Groq, the hardware company. And this is a good little teaser into stuff we don't talk about very much, or very often, the hardware side of things. So much appreciated. Be sure to follow us on Spotify as well. We are there in audio version. And we'll be back next time to discuss more interesting topics in the AI space. Thanks, everybody.